The squat is one of 3 events in a powerlifting competition. During the squat, there are 3 judges that watch the lifter and deem whether the lift is successful. The most common cause for a failed squat is improper depth. The lifter must descend until the top of their hip is parallel with the top of their knee. It would be useful in both meets and training to have a computer vision system that could make this judgment. Automatic squat depth detection can be broken into 2 parts. First, the localization of the knee and the hip, and second, determining the knee to ground and hip to ground distances. In this project, I focused on the first step. 2 existing approaches to part detection are poselets and the deformable parts model. For my implementation, I roughly followed the deformable parts model with some specializations. I built a multi-scale scanning window detector which uses histograms of gradients and pixel locations as features. I separately built knee and hip detectors and performed classification using an SVM. I also added a geometric consistency constraint that is based off the distance between the estimated knee and hip. Thus, my objective function to optimize consisted of 3 terms: a hip scoring function that quantified how much a proposed window looks like a hip, a knee scoring function, and a knee to hip distance scoring function. For each term, I included a weight which I fit through cross-validation. I collected and annotated 50 images from a Google search. Actual side view images from powerlifting meets are hard to come by, so I collected a variety of images from different contexts. My algorithm was able to correctly localize the knee in 70% and the hip in 55% of testing images. Without the knee to hip distance constraint, these values were 65 and 45% respectively. On the right is one of the images that was localized correctly. And here are a couple more examples where the algorithm performed well. And lastly, here's a couple examples where the algorithm struggled a bit. In each case, either the knee or the hip was localized incorrectly.